Hello everyone, we are discussing thermodynamics and we have seen the first law. Wrote down this question and let's see who can answer this. For a thermodynamic process, pressure is given as 2V plus 3V square. That's how pressure is defined. Find out work done by the system if volume changes from 4 to 5. V initial is 4, V final is 5. That's how pressure is given. Find out work done by the system. For any process, dW is always what? PdV. If we need W, we need to integrate this. What is pressure? 2V plus 3V square. Initial limit 4 and final limit 5. It's a simple integration of this type. What is integration of x dx? V dV. X square divided by 2. Similarly, what is the integration of x square dx? X cube by 3, V cube by 3. Four to 5. 2 cancel, 3 cancel. Let's put the limits. Upper limit means 5 square plus 5 cube. Learn how to use limits and integration. Use this 5 with both v square as well as v cube. Minus, and use a lower limit again with v square and v cube. 4 square, 4 cube. This is coming 25, 125, 175 minus 64 and 16, 80. One 125 plus 25, sorry, 125 plus 25. 125 plus 25 is 150. And this is 4 cube, 16, 64, 16, 80. 150 minus 80. The answer is coming 70. So far we have seen isobaric, isochoric, isothermal process, and we have found work for all these different processes. Now, there is a special process which is called an adiabatic process. What is adiabatic and all? We'll discuss this thing in detail. You just need to know that for adiabatic process, PV gamma is constant. P pressure, V volume. This gamma is adiabatic constant. What is adiabatic gas constant? Don't worry, we'll see this. As of now, it's just a constant for you. It's a constant number and its value is always greater than 1. Why? Later. As of now, it's just a process. PV gamma equals to constant. Now, volume is changing from V initial to V final. Pressure is changing from P initial to P final. And in this process, temperature also changes from T initial to T final. Nothing is constant. In isobaric, pressure is constant. In isobaric, volume is constant. In isothermal, temperature is constant. In adiabatic process, no energy is supplied. For adiabatic part, this dq thing is 0. If you have T inside a thermos flask, then that T is basically an adiabatic system. No energy transfer can take place between surrounding and that T. You don't have to worry about this thing. This, with the help of first law, will give us PV gamma equals to constant. As of now, it's just a number. Let's say 3, 5, things like that. Gamma is something which is greater than 1. Everything is changing. I'm giving you around 1 minute's time. Find out work done by the gas, that means by the system, in an adiabatic process. Let's see how many of you can answer this. Look here. How do we find work? Work is integration of dW. We need W, integrate dW. Start with this. What is dW? You don't have to worry about what type of process it is. दुनिया की कोई process हो, dW is always PdV. आपको सोचना ही नहीं है कि क्या था, आइसोथर्मल था या कोई और था. जो भी होगा ये होगा. Now, what is P? Look here. I cannot take this P out, but I can use this. This thing tells me that P is what? C upon V gamma. Some constant divided by V gamma multiplied by dV. I am giving you another 30 seconds. I hope you can integrate this type of thing. Integrate, put limits, and you will find the work. Now, how do you integrate something like this? C is a constant, take it out. This is dx, this is x to the power n, but this is in the denominator. Transfer it and it becomes v to the power minus gamma dv. And what is this? ये तो इस तरह का इंटीग्रेशन है भाई, x to the power n dx, इसका इंटीग्रेशन हुआ करता है x to the power n plus 1 upon n plus 1, and the only requirement is n should not be minus 1, because when n is minus 1, this becomes dx upon x, and integration is what? Log x. What is n? This thing. What is n? Minus gamma. Is this thing minus 1? No. It's always greater than 1. So, we can integrate this, and upon integration, you will get v to the power minus gamma plus 1 minus gamma plus 1. N plus 1 divided by n plus 1. That's how you get the integration done. Limits v initial to v final. We are integrating with respect to v, and therefore we are using limits of v. Now, when we integrate this, it will be c upon 1 minus gamma v final 1 minus gamma upper limit minus v initial 1 minus gamma. This is the work done. We'll further simplify this thing, but this is the integration part. V final 1 minus gamma upper limit minus V initial 1 minus gamma is the lower limit. Now, how do you further simplify this? Look at this. When you say PV gamma is constant, what does it mean? It means this. When pressure is P initial, volume is V initial, adiabatic constant gamma, whatever that be, and this is C. But it is also P final, V final, gamma. When it's P initial, you will be using V initial. When it's P final, you will be using V final. That means what is the value of C? It is P initial, V initial gamma, as well as P final, V final gamma. So what we are going to do is, when you multiply C inside, remember this step. If they ask this question in school examination, that's how you will simplify this thing. When you multiply C inside, when you multiply C with V final, you will take value of C as P final, V final gamma. When you multiply C inside with V initial, you will take value of C as P initial, V initial gamma. Let's do that. So when you multiply inside, do one thing, note down this first, and then I will multiply C inside. Always remember this, whenever we use x to the power n, n should not be minus 1. So this becomes C inside, P final, V final, gamma, and you already have V final 1 minus gamma. Minus C with the second term, P initial, V initial, gamma, V initial 1 minus gamma, whole thing divided by this number 1 minus gamma. What is this? Gamma minus gamma cancel. Both are V final, V final. Gamma, gamma cancel, V initial, V initial. This gives us what? P final, V final minus P initial, V initial whole divided by 1 minus gamma. This is work done in an adiabatic process. For short answer questions, for competitive examinations, remember this, and it's very easy to remember. What is work done? P final, V final minus P initial, V initial divided by 1 minus gamma. Note on this much and then try to represent this thing in terms of temperature, T initial and T final also. Now, let's convert the whole thing in terms of temperature. I mean, any type of process, it has to obey gas equation PV equals to nRT. चाहे किसी भी तरह की प्रोसेस हो, ये तो फॉलो करना ही होगा. PV equals to nRT, which means P initial V initial is nR T initial. Similarly, P final V final is nR T final. Initial, 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 final, final, final. That means this number, this is now P final V final minus P initial V initial, which is nR T final minus T initial divided by 1 minus gamma. I mean, just remember one of the formats. This one, and in this simply replace P final V final with nRT final, and this one with nRT initial, and you get this work in terms of temperature. Easy and important derivation, and these are important results. Note down this. Now, I have not told you anything about adiabatic process in detail, but with all the information which is present on the board, you can answer things like, write down the question. In an adiabatic process, as volume increases, what happens to temperature? In an adiabatic process, when volume increases, what happens to temperature? I mean, does it increase or decrease? That's what I'm asking you. Look at this. Look at this, and you can answer this. Well, mixed response. Look here. I told you that volume is increasing. कितना इजी था इस चीज को आंसर करना, देखना। वॉल्यूम क्या हो रहा है? इंक्रीज। अगर वॉल्यूम इंक्रीज हो रहा है तो सीधी सीधी बात है कि वर्क क्या होगा? पॉजिटिव। सोचना ही नहीं अपने को। वॉल्यूम इंक्रीज, दैट मीन्स पिस्टन इज गोइंग अप. Piston is going and moving in the direction of force, and therefore work will be positive. This is the first information. Now, work is coming positive, but look at the denominator. 1 minus gamma. Gamma is greater than 1. Denominator is negative. If this is negative, we need positive work. That means numerator should also be negative. Negative will give you what? Positive. That means what? T final minus T initial should be negative. Or it is telling you that if volume increases, temperature decreases. So you've got another important statement for an adiabatic process, that in adiabatic process, as volume increases, temperature decreases. We'll learn a better method for remembering this when I teach you adiabatic process. That is so easy that you can still remember that. And why does it happen? We'll discuss when I teach you adiabatic process. When you spray dew, तो अपने को ठंडा सा फील होता है. That spray, when it comes out, volume increases, and suddenly this is a sudden process, sudden volume increase, and that results in what? Lowering of temperature. क्या कहानी है इसके पीछे की? बाद में. अभी के लिए this format and this thing together with work positive, ये अपन ने कहाँ किया था? फर्स्ट क्लास में. We can easily answer questions like these. Note down this. Now, let's develop graphical method of finding work. Write down finding work using P versus V graph. Finding work done by the system using pressure versus volume graph. The only thing you need to know is this. If you have a graph of y and x, this is the graph. X initial, X final. Then all this area under the curve, this whole area between the graph and horizontal x-axis is given by y dx x initial to x final. We have done this thing in kinematics. If we plot a graph between velocity and time, then area of that graph gives us what? Displacement. So I hope you remember this thing. Now, if we have been given a graph between pressure and volume, this is the shape. From V initial to V final, if we can find this entire area, this. If you can find the total area A, then that will look like this. On the vertical axis you have P, on the vertical axis you have Y. So this is P multiplied by dx, which is V, dV, lower limit, upper limit. But you know that P dV, V initial to V final is nothing but work done by the system. This is the graphical approach of finding work. In P versus V graph, if we can find total area covered by the graph between graph and the horizontal axis, then that area will give us work. Now area is a scalar thing, so you will also remember that if volume is increasing, you will take that work as positive, and if volume is decreasing, your work will be negative. Draw this figure, but first draw this and then we'll write a statement. Write down the statement. In a PV graph, pressure volume graph, area between the graph and volume axis, area between the graph and volume axis gives us work done by the system. Area between the graph and volume axis gives us work done by the system. If volume is increasing, work will be positive, and if volume is decreasing, then work will be negative. So, first draw P versus V graph for an isobaric process. I'll give you 30 seconds. In an isobaric process, volume is changing from V initial to V final and pressure is constant throughout. Let's say P naught. So you need to draw a graph and then use the concept of area, find out work, and if your work is coming same as you got with the integration method previously, then write yes in the comment box. Listen again. What I expect from you: for an isobaric process, draw a P versus V graph. Pressure is constant, P naught. Volume is changing from V initial to V final. Let's say it's increasing. Draw the graph, find the area. If your work is coming same, write down yes in the comment box. Do it fast. It's an isobaric process. How do you draw an isobaric? Pressure is constant. This is your isobaric process. This is V initial. This is V final. And the arrow is telling you that volume is increasing, although you can see this is initial and this is final. And this is P naught. So this is the graph for an isobaric process. For any value of V, volume, pressure is what? Constant. So a short answer question for school examinations, that draw graph of an isobaric process, that's how you draw it. Now, we need work, and for that we need this area. Area will give us work, volume is increasing and therefore we'll take it positive. Now, I hope you can see the rectangular portion. This rectangular portion shown in red. What is length of base? V final minus V initial. And what is the height? P naught. So what is work? Area. And what is the area? P naught into V final minus V initial. Kadam. This is the graphical approach. अगर आप एरिया निकाल दोगे वर्क मिल जाएगा. Note down this and answer this. Draw a graph for isochoric in isochoric. You know what to do. Draw a graph of an isochoric process, and then once your result matches with the one we already got in previous lecture, write down yours in the comment box. Good, many of you are saying yes. So how do you draw a graph of an isochoric process? This is a graph. Volume, let's say, is V naught, not for a constant value. Pressure is changing from P initial to P final. Graph is running from this point to this point. Volume is increasing, pressure is increasing, and volume is constant. So many times what people do, they go for this area. So if you find this area, remember A is not W, because look at the statement. The statement tells us that area between the graph and volume axis. So how do you find this area? Look here, this is the graph. This much is the area. Now, if I make it more inclined, this is the area. More inclination. I hope you can see that area is almost disappearing. And therefore, if it's a vertical graph, there is no projection on the volume side. Or simply, you have a rectangle whose base is of 0 width. There is no base right here. We are not interested in this area. So the moment your graph becomes vertical, you found that A, not this A, not this A. Your A is basically 0 and therefore work is what? 0. Note down this and also don't forget to show this part. This A is this A. Let's do one thing, call it A dash. To avoid confusion, call it A dash. A dash is not W. The A we are interested in is the area between graph and volume axis, which is 0. Graph is from A to B. This broken portion shows that graph line is passing through the origin. There are n number of moles. This is T naught, this is 3 T naught. And right when temperature is T naught, that means at point A, pressure is P naught. What is pressure at point B? We have no idea. They have not given us. So a thermodynamic process takes place from A to B such that temperature changes from T naught to 3 T naught. Find out work done by the system. Not a single correct answer. Maybe because of this fact that you're trying to find area of this graph. The question is given just so that you don't do this. If somebody goes for this area, it is not work. Why? Because work is calculated when graph is plotted between P and V. Whereas this is what? Temperature. Look at the statement which we have written. Area between graph and volume axis in P versus V graph. This is P versus T. तो ऐसा नहीं है कि आपने ग्राफ देखा, उठाया, एरिया कैलकुलेट कर दिया और आंसर आ गया ना, ऐसा नहीं होता. Show this red portion, write down A, and then A does not represent work because this area is between graph and temperature. So this is just to give you an idea that why not every area should be considered as work. Then how do we find work? छोटी सी मैथ्स और आप ये कर सकते हैं. कैसे देखना? Well, tell me fast. This is y, this is x, I have a line. What is the equation of this line? Write down fast in the comment box. Y versus x. I have a straight line which is passing through origin. What is the equation of this line? Write down fast in the comment box. It's only y equals to mx. No c. C is used when line cuts an intercept. This is y, this is x. If line cuts an intercept, then equation is given by mx plus c. If you have any confusion, ask for the lecture and I will give it to you. This is c, intercept. This is theta. M is tan of theta. Which means what? Look here. This graph is between P and T. देखना यहाँ पर. For this graph, you're basically saying that P is M T. M is some constant. What is that constant? Tan of theta. It's a constant. Why? Because आप कहीं चले जाओ, ये angle हमेशा क्या है? Theta. क्यों? Because this is a straight line. So, this is y, this is x, t and t. अगर straight line है passing from the origin, then it is what? P equals to mt. लेकिन P, V, आपको पता है क्या होता है भाई? nRT. P, V is what? nRT. That means what? P is n r upon v multiplied by t. You've got 10 seconds to answer the question now. What is work done by the system in this graph? 10 seconds. Everything is on the board now. In 10 seconds you can answer the question if you are careful enough. Not a single response. बहुत इजी चीज पूछी है मैंने आपसे. एक बार और हिंट दे रहा हूं. P is mt. M is a constant. Now try to answer this. If we have a straight line graph, then this part, which is coefficient of t, is a constant. बहुत सही. अब लोगों ने आंसर देना शुरू किया. Good. So once you say that m is a constant, what is constant? Coefficient of t. What is coefficient of t? This thing inside the red bracket. What is inside the red bracket? N, number of moles, that is a constant. R, constant. V, ये है काम का. This process says that your V is basically constant. तो स्कूल एग्जामिनेशन में ग्राफ कैसा आएगा? P वर्सेस V. कॉम्पिटिटिव एग्जामिनेशन में ग्राफ कैसा आएगा? P वर्सेस T. बट कैन यू सी कि उससे भी ज्यादा इजी है. The moment you found that graph is passing through origin for P and T, it is basically an isochoric process. और अगर आइसोकोरिक है, वॉल्यूम कांस्टेंट है, तो बच्चे को बताए कि यार इस केस में तो वर्क क्या आना चाहिए था? 0. and therefore work done for this process is 0. If you understand this part, write down yes in the comment box. This is a graph between volume and temperature running from A to B. Temperature is changing from T0 to 3 T0. Volume at A is V0. Take number of moles as N. Find out work done by the system. Should not take more than 30 seconds now. Good, one of you has answered this thing. Let's start step by step. Answer in the comment box. What type of process do you see? What is this process? Isothermal, isobaric, isochoric, or any random process? What type of process do you see when a graph is plotted between V and T and is of this shape? Good. So almost everyone knows that it is an isobaric process. Let's be fast. Graph is between V and T. Let's call it V equals to MT. V T. But P V is N R T. That gives us V as N R upon P multiplied by T. This part, which is coefficient of T, for this is a constant. Everything inside the bracket. If everything inside the bracket is a constant, that means P is constant. Easy है, जैसा पहले था वैसे यहाँ पर है. If P is constant, then it is an isobaric process. And for isobaric process, I hope you remember work done. It was nR T final minus T initial. ये result था. We developed this thing in the last lecture. So what is work done for an isobaric process? nR T final minus T initial. आगे बढ़ने के पहले look at the trick. ये किसका work है? Isobaric. What is work done for an adiabatic process? Trick wise याद रखना. Divide the whole thing with 1 minus gamma. In adiabatic process, the way you remember the results. For isobaric, nRT final minus T initial. For an adiabatic process, nRT final minus T initial whole divided by 1 minus gamma. As a trick, you can remember that. Now, for this question, we have got nR. We don't have to worry about what is that final volume corresponding to B. You don't have to worry about that. Why? Because they are interested only in what? Initial and final temperatures. What is the final temperature? 3 T naught. What is the initial temperature? T naught. Done. The answer is nR 2 T naught. And this is basically an isobaric process. Note down this. One of you is asking what is the significance of A and B. There is no significance. A means starting point. Starting point means you have a gas inside a piston. Under the piston you've got the gas. And right here temperature is T naught. Volume is P naught. So this initial stage is being called what? A. Now then you supplied heat to the system, and when you supplied heat to the system, it becomes this. Its volume increases, temperature becomes 3 T naught. So you can see that if you are tripling the temperature from T naught to 3 T naught, this part is constant and volume will also triple. So you can directly say that volume this time is what? 3 V naught. Volume corresponding to this, you can immediately say is what? 3 V naught. So when volume is 3 V naught, temperature is 3 T naught. This stage, let's call it B. So A and B are nothing. I mean, it's just saying that graph is running from A to B. A is that stage where you have your temperature as T naught and volume as V naught. And B is that stage where temperature is this and that. Write down work done in a cyclic process. So this is a cyclic process. Let's take an easy elementary process. This A, B, C, D. The process runs from A to B to C to D and back to A. Now, we need to find work done for this process. We need to find work done for A, B part, work done for B, C part, work done for C, D part, work done for D, A part. Write down fast in the comment box what is work done for B to C and what is work done for D to A. I've given you nothing. It's a graph between P and V. What is work done from B to C? What is work done from D to A? Fast. Good. These are isochoric parts. So these are isochoric parts, then BC 0, DA is also what? 0. Isochoric, isochoric. अब यहाँ देखना fast. Look at this AB portion. AB. We'll use numerical values and then we'll write the statement directly because it's a very easy and statement type question. Just concentrate on AB part. A to B. If I need work done for A to B and graph is between pressure and volume, then I will immediately go for what? This much area. Area between graph and volume axis. थोड़ी देर के लिए मान लो ये हाइट कितनी है 10. The whole thing is 10. Base 3. थोड़ा फास्ट कर लेते हैं और इजी चीज है. The height is 10. The complete height is 10. This is 10. और यहां से यहां तक का जो वॉल्यूम डिफरेंस है that is 3. What is the area? This area is what? 30. What is work done? AB 30. Then either. Let's now concentrate on CD part. CD. We need the area. I hope you can see that base is still what? 3. Base अगर ये 3 था तो भाई ये भी क्या होगा 3. But suppose this part is your what do you want to take? Let's say 4. This is 4. Pressure corresponding to this isobaric portion is what? 4. This is 4. ये जो area जाएगा अपना यहां से यहां तक this much only, this much only. What is the area? Carefully देखना. What is the area? 4 into 3. 4 into 3. But I hope you can see that work is what? Minus 12. Why? Because from C to D, as you move, volume is decreasing. आगे होगा, कुछ difficult नहीं है. CD is giving us what? Minus of 12. So what is total work? 30 minus 12, which is coming what? 18. 18. अब आगे से ये सब कुछ नहीं करना है, ये समझने के लिए था. आगे से क्या करना है? What is this height? 10. What is this much? 4. So what is this length? Height of the rectangle. 10 minus 4. Height of the rectangle is what? 6. What is the base? 3. So what is the area? 6, 3, 18. Area is coming what? 18. And now, if your cyclic process is clockwise, then work is plus 18. Had it been an anti-clockwise one, the work will be minus 18. If it's an anti-clockwise, तो क्या change आएगा? यहाँ volume increase हो रहा होगा, तो आप इसको बोलते हैं प्लस. एंटी यहां वॉल्यूम डिक्रीज होता तो आप इस वर्क को बोलते, इस जगह पर जो वर्क आता वो 30 ना होगी, क्या होता? -30. चीज क्या हो जाती? चेंज. व्हाट इज द स्टेटमेंट फाइनल फॉर साइक्लिक प्रोसेस? फॉर एनी साइक्लिक प्रोसेस, वर्क डन इज एरिया इनसाइड द साइक्लिक कर्व. And if process is clockwise, work is positive. If process is anti-clockwise, work is negative. Write down the statement. For a cyclic process, work is area inside the cyclic curve. For a cyclic process, work is area inside the cyclic curve. If it is a clockwise cyclic curve or graph, whatever you say, if it's a clockwise cyclic curve, then work is positive. And if it is an anti-clockwise one, then work done is negative. Work done is negative. If you wish, you can draw this thing fast. Suppose both these things have an area of 5. तो आप इस पहले वाली के लिए वर्क बोलेंगे 5 और दूसरे वाले के लिए आप वर्क बोलेंगे -5. Clock positive, anti-clock negative. 5 represents area inside the cyclic curve. If you understand this concept of cyclic process, then write down yours in the comment box and then you can leave. Thank you very much.